Risk management planning is the process of reflecting on what could go wrong and developing risk management strategies to either eliminate the risk or reduce its impact on the project. In complex systems projects, risks commonly arise from lack of experience, lack of control, lack of information, and lack of time. For example, we often lack experience in the technologies we're applying. The result is unplanned time and effort spent in learning and reworking non-performing designs. When we contract development services or purchase components from external suppliers, we give up direct control of delivery schedules. This can expose us to late delivery of the integrated system. With critical activities such as requirements capture, we depend on external organizations for information. For example, we depend on the customer for a complete and correct statement of requirements. Incomplete requirements can result in the delivered system not meeting the customer's needs. Our projects are chronically time poor because we set unrealistic delivery schedules. This is often the result of underestimating the effort needed to deal with project size and complexity. To analyse what could go wrong on this project, we'll perform risk assessments when developing each work package in the WBS. For each risk identified, we'll determine its probability and severity of outcome. For a comparative analysis, we'll then rank each risk using a probability severity matrix. We'll then develop risk management strategies. All risks have some root cause. These causes present threats to our project. For example, lack of experience in a new technology is a threat. In the presence of a threat, we may have an unwanted outcome where we lose control of a situation. For example, mistakes made in applying a new technology may require us to rework our design. When we lose control, there are consequences. In this case, design rework may cause cost and schedule overrun. We can reduce the probability that we'll lose control by introducing risk management strategies that act as barriers to loss of control. For example, we can avoid rework by budgeting for technical investigation and prototyping of new technologies. If we accept the risk, which means we don't introduce barriers, or if the barriers we do introduce fail, and we do experience the loss of control, we can still reduce the severity of the consequence with a contingency plan. In this case, to make our delivery deadline, we could deliver a subset of system functionality. That is, the critical set of functions the customer needs on day one. With these strategies, we hope for the best but prepare for the worst. Most of the time, we have no choice, unless of course we can avoid the risk altogether by not proceeding with the risky activity. For example, in this case, we could choose to employ proven technology. Alternatively, if we must use new technology, we can transfer the risk to another party who is more capable of managing it. For example, we could contract out risky subsystem development to specialist organizations. To summarize, we can manage risk by avoidance, where we don't engage in the risky activity; prevention, where we take proactive steps to reduce the probability and severity of the unwanted outcome; mitigation, where we accept the risk and develop contingency plans as a buffer against loss; and transfer, where we transfer the responsibility for the risk to another party. The results of our risk assessment are recorded in a risk register. For each risk, we'll reference the work package activity, describe the risk scenario, document its probability and severity, and rank the risk using the risk matrix. Where possible, we'll quantify its impact on project cost, scope, schedule, quality, and safety. We'll describe our risk management strategy, we'll nominate responsibility for managing the risk, describing who will do what and by when. If we've accepted a risk, we'll describe our contingency plan should the risk scenario be realised. Lastly, we'll nominate how often the risks should be reviewed in the course of the project. To help us focus on high-risk activities, we sort the risk register by rank. A top 10 risk list will be published on the project intranet. The register provides a mechanism for tracking and controlling risk throughout the project. An up-to-date risk register demonstrates a project's commitment to formal risk management. At project commencement, the overall approach to managing the project's risk profile is documented in a risk management plan. The plan identifies significant risks, focusing on the top 10 risks from the risk register. It outlines a broad strategy for risk management. It specifies resource requirements. It identifies risk management responsibilities, nominating who identifies risks, who proposes actions, who approves actions, who performs actions, who verifies actions are complete, and who maintains the risk register. It also describes the process for risk monitoring and control during project execution. To conduct a project is to be in a state of perpetual risk. Things will go wrong. We can choose to ignore risk, and to quote Shakespeare, suffer the slings and arrows of outrageous fortune. Or we can act with vigour and take arms against a sea of troubles, and by opposing, end them. On this project, we'll take the purposeful and sometimes painful steps to prepare for and hopefully avoid the unimaginable. This is the essence of risk management.